All right, so this one's a little bit different just because of the language that it's using, but it says if S of t equals 6 over t plus 2, if that's a measure of feet traveled with t measured in seconds, it wants us to find the average velocity between t equals 3 and t equals 7. And it wants us to find the instantaneous velocity at t equals 4. Now, when it talks about average velocity between 2 points, what it's asking you to find is the slope of the secant line. When it's asking about instantaneous velocity at a specific point, it's asking for the slope of the tangent line. So we're going to use technology a little bit more to do this problem. So let's get our calculator out. And what I want to do is go ahead and graph this first. Now, there's a couple of things to be careful of. If I'm going to put 6 divided by x plus 2, that x plus 2, some of you are going to forget to put it in parentheses. So be really careful that that needs to be in parentheses. You can also, if you hit alpha y equals, it gives you some options right here. And I can hit enter on the n over d, and it actually lets me put a fraction in the y equals. So I'm going to do that. I'm going to put 6 on top, and then I'm going to put x plus 2 in at the bottom. Now that I have my graph, I'm not that interested. I mean, we can look at it. This is what the graph looks like. And I'm interested in the slope between this point right here and this point over here. So really all I'm interested in is my table. So I'm going to go to my table, and I'm going to plug in these couple of values. Let's clear what we have in there now. Oh, we have them in there now. So I'm looking at when x is equal to 3 and when x is equal to 7. Let's clear these two out if I can. Oh, maybe it won't let me. So x is equal to 3. When x is equal to 3, y is equal to 6 over 5. When x is equal to 7, y is equal to 2/3. So I can transfer that information right over here. I can say when x is 3, y is equal to 6 over 5. And when x is 7, y is equal to 2/3. And those are pretty nice numbers to work with. Now I just have to put them in the formula. So the slope of my secant, and let's call this x1, x2, y1, y2. So I've got to do y2, which is 2/3, minus y1, which is 6 over 5. And I'm going to subtract x2, which is 7 minus 3. And that's going to give me the slope of my secant. So 2/3 minus 6 over 5. So let's just go, we'll just keep doing this. We'll let technology do the work for us. We're going to find out the top first. So let's do 2/3 minus 6/5. And that tells me negative 0.5 and then a bunch of 3's. On top, and then 7 minus 3, I better not use my calculator for that one. That one's 4. So negative 0.533333 divided by 4. I'm going to go ahead and I'm going to divide it right here. Because one thing I don't want to do is I really don't want to round until I have to. On the AP test, it wants you to round to 3 decimals. So you should be rounding to 3 decimal places. And you want to be really careful when you do that. You don't want to round too early and get rid of stuff that you could need later. So negative 0.1, negative 0.133 is a very acceptable answer right there. Okay. Now I want to find my instantaneous velocity at t equals 4. So one of my x values is going to be 4. And I want my other x value to be really, really, really close to 4. So let's call this x1. Let's call x2, how about we do 3.999. So my y1, when x is equal to 4, 6 over 4 plus 2, that's just 6. So 6 over 6, my y is equal to 1. When x is 3.99, I don't want to plug that in. I'm just going to use my calculator. So I'm going to go to my table, and we're going to plug in. We could double check 4, make sure we did it right. Yep, it's 1. And then let's plug in 3.999. When I hit enter, I get 1.0002. So my y2 is 1.0002. So I've got my 2 x's and my 2 y's. So the slope of my tangent is going to be equal to y2, 1.0002 minus y1 over x2, 3.999 minus x1, which is 4. So 1.0002 minus 1 is just 0.0002. And 3.999 minus 4 is going to be what? 0.0001. Nope, let's get out of here. 3.999 minus 4 is going to be our negative 0.0001. Okay, so when I divide these, I got no, we are at negative point. We have an extra 0 here. 0.0002 over negative 0.001. And when we divide that, we're going to get negative 0.2, which if you plug in your own numbers, depending on, did you do 4.0001? Did you do another 0.9? Depending on exactly what numbers you use to put in there, this estimation might be a little bit wrong. Remember, this is an approximation. So if you are, for example, on the calculator, it's tangent. When you ask it what the tangent line is at x equals 4, it gives you that it's at about negative 0.17, because we're at an approximation. So the further out our decimal goes, the closer that we get to 4 without getting to 4, the closer our approximation is going to be. But 3/100ths, that's not too bad of an approximation. Now, in the next chapter, we're going to show you some ways to do that, to find exact answers without having to do all the guesswork.